traditional metric will tell you CPU is at 90%. Okay, that's great, but like, where is it running in my environment? What's the software version of the build, for example? What Kubernetes pod am I running on? In what AWS or Azure account, for example? Like, all of that metadata needs to be tapped on.
OpenTelemetry and observability in general are amazing. They can be really noisy. They can provide a lot of data. It can become significant noise.
And really started getting a feel for what you can do with logs. Very powerful, but they were missing something. Context and correlation, right? You knew that something happened. You didn't necessarily know why. And stitching that story together was actually very hard.
Steve, I noticed there's a book behind you, Mastering OpenTelemetry Observability. It's way back in the distance there. I'm squinting to try and read it. Yep.
And that makes it hard to actually achieve observability because you can't ask like unknown questions to your system and get quick responses.
Steve is wearing a great t-shirt. It says, "Oh, tell me more." So I love the little tie-in to OpenTelemetry there. If I ever travel somewhere, I think I'm going to hit you up on LinkedIn and ask you for some recommendations probably.
What some people have joked about is my next book should be about travel.
Welcome to Incidentally Reliable, the podcast by Xurrent, where we sit down with engineers, leaders, and operators who are solving the toughest problems in site reliability. I'm your host, Jim Hirschauer, and in every episode, we go beyond the war room stories to find out what reliability really means to people who are actually building it. So let's jump into that. I'm excited about my conversation today. I'm joined by Steve Flanders. Steve, welcome to the show. If you could, why don't you just tell us a little bit about yourself?
Hey, thanks so much for having me. Really excited for our conversation today. So I'm a senior director of engineering at Splunk, which is part of Cisco. I work in the observability business unit. I'm kind of deeply involved with everything traces, metrics, and logs at this point, as well as the OpenTelemetry community, which is an open source project that I'm very passionate about. My background spans almost 2 decades in the monitoring and observability space. I started more as a practitioner, kind of running SaaS, PaaS, IaaS services at scale and trying to solve the problem of reliability at the end of the day. How do you keep systems performing well, have the right customer expectations? And things have evolved quite a bit. I remember back in the day, I was writing Perl scripts to kind of parse logs and help network engineers actually be able to troubleshoot their network setup, right? Configuration changes, topology changes, network traffic congestion problems, things like that. And while that was great, I love Perl. I miss those days. Very hard to understand, but a very cool programming language. There are some great tools out there. I got introduced to one called Log Insight, which was at VMware. And I actually brought this to my networking team and was able to have them kind of self-serve, where they could define their own queries, their own dashboards, their own alerts, and start to figure out problems in their environment. And that got me really passionate about the space. I actually switched from the operations side to the engineering side. I have a computer science background by trade. And I actually joined the Log Insight team, actually running it for VMware, both from an on-prem and a SaaS perspective. And really started getting a feel for what you can do with logs. Very powerful, but they were missing something. Context and correlation, right? You knew that something happened. You didn't necessarily know why. And stitching that story together was actually very hard. At VMware, I actually tried to encourage the different product lines to change their logs so that we could pass this context. And it proved to be just too difficult. Right. So eventually I ended up leaving. I was part of the founding team at a stealth startup called Omnition. We were in the APM, or application performance monitoring space. And we built a modern APM solution for the distributed cloud native world. We also got involved in the Open Census project, which was the precursor to OpenTelemetry, and built the Open Census service, which is now the OpenTelemetry Collector. So I've been involved in both the Open Census and OpenTelemetry projects kind of from the very beginning. And we were lucky enough to get acquired by Splunk a few years ago. It is now the Splunk APM product. That's what Omnition became. And I've had the ability of running both Splunk Observability Cloud and now the Splunk App Dynamics product lines, just really trying to make it easier for people with all the influx of data that they're getting, which is just becoming more and more of a problem.
Yeah. Wow, what an amazing background. And for anyone who's listening to the audio only version of this podcast, Steve is wearing a great t-shirt. It says, "Oh, tell me more." So I love the little tie-in to OpenTelemetry there. You mentioned something interesting about the amount of information coming at people. While OpenTelemetry and observability in general are amazing, they can be really noisy. They can provide a lot of data to anyone who's on the receiving end of that. It can become significant noise while you're trying to figure out what is the signal in all of this noise. And it really depends on configurations, I think. You can instrument a lot, you can instrument a little, and how you surface that becomes really important. So I had a conversation recently at an SRE day that I attended, I spoke at as well, and the conversation was around signal to noise and how do you really cut through all of the noise that just in general observability and monitoring systems are introducing these days. So, what are your thoughts on that? Do you see that as well? Do you see that there's a lot of companies that the way they configure it, they do generate a lot of noise? And if so, how are people managing that?
Yeah, this is a real problem. I think it's only getting worse because we have more distributed systems that are talking to each other, more load on these systems. And even in the AI era, there's just so much data that's being generated. So I wholeheartedly agree with the pain point that you're raising here. And it's an interesting problem because you need telemetry data to actually achieve observability. If you don't have enough of it, right, you will have blind spots. But the flip side is if you collect everything, there's just so much noise. Like, how do you find that needle in the haystack and actually find the insights and be able to reduce time to detection, reduce time to remediation? That's kind of the balancing act. And different solutions have different approaches to this, right? Like in the APM space, sampling is quite common. Can I do some sort of intelligent sampling where I get enough signal and hopefully minimize the noise? Because every 200 OK probably doesn't need to be collected. But maybe every 500, 503, 404, I want to have at least enough of those to understand the patterns and behaviors that are occurring. That's really the trade-off in my opinion. The other part is, I mentioned context and correlation earlier. That's becoming even more important today, but that is more data at the end of the day. You're actually trying to stitch traces, metrics, and logs together. Maybe I need to pass some business context between that. That metadata is not free, right? There's high cardinality is a very common problem. How do you sort through that where you can actually get quick insights and not do it in a very expensive way? Because keeping all of this data is kind of expensive. I think OTel can help a lot here. I think that there are different strategies like sampling or the way that you approach alerts, and maybe we can drill a little bit more into some of those in our conversation today.
Yeah, I would love to. First, I want to back up for a second. You used a term that I don't know if everyone understands what that term means. So high cardinality. Why don't you define that term for us?
Yeah, so probably the easiest way, I like to use metadata because that's the most common way you're going to see this high cardinality problem. So metadata is just kind of key value pairs. So name equals value at the end of the day. Metadata is important because it tells you something additional than what the telemetry data gives you. So a traditional metric will tell you CPU is at 90%. Okay, that's great, but where is it running in my environment? What's the software version of the build, for example? What Kubernetes pod am I running on? In what AWS or Azure account, for example? All of that metadata needs to be tacked on. High cardinality is really how many different unique values do you have for a particular name? So something like a build version, you might have 100 different build versions because you're incrementing them every week, for example, and they just kind of get larger. You could have a user ID where you have millions of users. Well, now you have millions of unique values for that user ID if you're tagging that piece of data. High cardinality is a hard problem because for each of these telemetry data points that you're collecting, there could be a unique value that you care about, and you want to be able to break down the data by that dimension, by that value. That's high cardinality. And to do that at scale and at speed is not easy. You typically need some sort of columnar store or in-memory kind of representation so that you can quickly kind of slice and dice. If you're just storing it on like S3, like a blob store, for example, it can take a really really long time to get some of these insights. And that makes it hard to actually achieve observability because you can't ask like unknown questions to your system and get quick responses, which is often necessary, especially when you're in an active incident.
Yeah, there's nothing worse than a slow system where you're trying to diagnose an ongoing severity 1, P1, Sev 0, P0, many names in many different companies, but customer impacting incidents, anything responding very slowly is going to be really frustrating. So let's dig into this issue of so much data and so much noise. You've kind of alluded, I think, to a couple of potential strategies for starting to cut down on some of that noise. What are the things that you think are really the most impactful, the most effective that really everyone should be considering as they're trying to get to as pure a signal as they can through all the noise?
Yeah. So, I mean, my personal belief is that projects like OpenTelemetry, some sort of standard way of generating, emitting, processing this telemetry data is pretty essential because you need that standardization for two things. One is to provide the context and correlation I was talking about. In OpenTelemetry, they call it semantic conventions. Mm-hmm. So like HTTP status codes, I was giving you examples of 200, 404, 500, right? Those types of names need to be normalized in some way, shape, or form. So it doesn't matter whether I'm on like a Python client or a Java server or I'm running on Kubernetes. We all call it the same thing. Because when we do that, then we can actually start stitching together and understanding the behaviors of our system in a consistent way. So I'm a big fan of adopting something like OpenTelemetry. Now, that's easier, of course, in greenfield environments. In brownfield environments where you may already have instrumentation libraries or maybe even data collectors, it can be a little bit more work. My general guidance here is try to at least introduce the OpenTelemetry Collector between your services and wherever you're sending your observability data, whether that's to your own like data lake or open source project or to a SaaS solution or a vendor. Doesn't matter, but if you can put the OTel collector in the middle, and it supports a wide range of instrumentation things, open source projects, you name it. So it's pretty extensible and can support most technology stacks that are out there today. This is going to give you the first ability to start standardizing things. Because what the collector does is it can accept in one format and it can emit in a different format. And because of that, along the way, it can add this standardization layer, for example, semantic conventions, as it's emitting the data. That's extremely powerful. And it gives you control of your data because now you can control at the OTel collector level what is being sent, whether you're enriching it, whether you're redacting some information, where you want to send it, if you want to send it to multiple destinations or not. It gives you control. Nice. That's kind of the first step, in my opinion, to get in front of this data problem, right? How do I send the right data? Now, once you have something like the collector in place, some people kind of use it more like a forwarding engine, like maybe it's a translation layer. I accept in this format and I export in a different format. But the power is when you don't use it as a forwarder. You use it more like a control plane for your observability data. So this is where you could, for example, add tail sampling processing if you're using traces. And you can control like, hey, I want like this percentage of my errors to be collected and I want this percentage of my non-errors to be collected. Again, that control aspect. Or maybe you're missing metadata. I mentioned context and correlation. If for whatever reason your existing applications are not admitting the metadata that you need, the collector will allow you to enrich the data before you send it to its final destination. That's extremely kind of powerful. Now, the final step would just be on the back end, wherever you're sending this data. At some point, you have to make some decisions there, like, is this data valuable to me? So kind of two things come to mind. One is dashboarding or querying. How do you determine whether or not you're actually querying over the data that you're collecting? Because if you're not, then why are you collecting it? It's just kind of waste. But maybe the more relatable one, especially for people in the reliability space, are the alerts. You don't want threshold-based alerts. You want more SLO-based alerts. You want to understand whether like your error budget's being exceeded, for example. You want to understand what the business impact or the customer impact is of these alerts. Otherwise, the alerts become noise. You're paging people all the time because CPU is high. Maybe CPU being high isn't a problem, or maybe there's something else that's resulting in that you should go focus on instead of that high CPU. So my big 3 takeaways would just be around like standardize so that you can control your data, control what you keep at the end of the day, and then finally only page for like what users are actually feeling in terms of pain. Don't page for everything. Those 3 things I think can make a world of difference.
Yeah, love it. Those are really great, direct, actionable insights. What I'm curious about is kind of the level of effort required. So let's say, a couple of scenarios. Maybe I've already have OpenTelemetry in my environment or throughout my estate. And I'm collecting a lot. Maybe I'm collecting too much right now. What's the level of effort to go back and really do a review and look at those 3 items that you mentioned? And then from the other perspective, it's not there yet, and I really need to get it in place. What sort of effort am I looking at?
Yeah. Look, this is not free at the end of the day, right? Projects like OpenTelemetry start to make it easier to standardize and collect data. But when you want to start controlling that data, that is more of a lift on the end user at the end of the day. So I just want to be like upfront that this is not a free effort. You can do simple things like, again, going back to sampling. Enabling this sampling processor, it already has some like built-in rules that you can take advantage of that are good places to start. Are they perfect? I mean, every environment's a little bit different, so you might need to tweak it. But there's enough there where you can do some intelligent sampling that's pretty lightweight. But if we realistically want to look at like what of the telemetry data is actually being queried? Is it actually valuable? Am I doing it like every day or like once a quarter? That requires a deeper analysis. I think you have 2 primary options here. So one is it depends on where you're sending your data and whether that backend provides some of these capabilities for you. Some of them do, some of them don't. So some will provide an analysis saying, hey, for this particular metric, as an example, you've used it in these 3 dashboards this many times. Great, I know now that something meaningful is happening with that data. And it will also say, hey, these dozen metrics, you've never queried over the last, 30, 60, 90 days. Well, I would start there. If you know that certain things aren't being queried over either from an alerting or dashboard perspective, that immediately raises the question of, is this actually valuable or not?
Yeah.
Second is some of these backends will start to do some of these cardinality assessments for you, or even like aggregation things like HTTP 200 status OK. If you can start understanding what are your largest sources of telemetry or your highest cardinality things, you can start eyeballing these and determining whether or not they're providing real value for you and whether or not you want to drop them. Now, some observability or platform backends don't provide this capability. Now I would use the OTel collector, right? Because that's within your environment. You can actually fork this off. You can run your own processors. You can extend the OTel collector, but you can start looking at the data yourself and deciding what you want to do. Some of the more advanced end users that I've seen will typically fork off the exact data that they're sending to their observability backend to either something like a message queue like Kafka or directly to a data lake. And they'll start doing data warehouse type analysis on top of the telemetry data to get these insights if their backend that they're sending it to doesn't provide it for them. But this is manual, right? Maybe you're lucky enough to have a data science team that will analyze that for you. Maybe you have to do it yourself. It's not free. And then once you figure out what the patterns are, you then need to go update your configuration. Ideally, you want to catch this as close to the source as possible. At the very least, you want to catch it at the OTel collector level before you emit it. Now you're going to have to make configuration changes. Well, that can change your CPU memory utilization of the collector. You might need to scale it out, right? There's even operational aspects as a result of adding some of these processors or maybe even regular expressions if that's what it requires to tweak your telemetry data. So the investment here, I think, needs to be over time. Yeah. What problems are you seeing? Which of these data sources are not valuable? And over time, slowly starting to refine this and make it better.
Yeah, it makes a lot of sense. There is no free lunch. We know that, right? It takes effort to get these things tuned well. But the alternative is you're going to get flooded with data. You're going to get flooded with alerts. You're going to stop paying attention to those alerts, and you're going to miss the signals that are indicating you have an imminent issue that's going to cause impact for your customers.
That's right.
So, putting in that work should be worth it. The assumption is that our management layers, our executive layers want us to have a nice, reliable system that we can proactively detect issues within. Steve, I noticed there's a book behind you, Mastering OpenTelemetry Observability. It's way back in the distance there. I'm squinting to try and read it. Yep. Is this information in that book? Tell me a little bit about it.
Yeah. So the goal was to cover both observability and OpenTelemetry, right? Like, what is the space? How do you kind of get started? I try to cover it from both angles, greenfield and brownfield environments. I cover it from all the aspects of the OpenTelemetry project and how you can get started. I mean, we talked a lot about OTel Collector, but there's instrumentation libraries, there's a full specification, there's a lot more about semantic conventions, and there are additional parts of the project that we didn't even dig into today that I cover in the book. And then I talk about the observability part, like how do you store this? How do you start analyzing it? And things like this come up, like what are some of like the pitfalls and anti-patterns that people do, like collect too much data or collect too little data or not provide context and correlation, and how do you deal with that? So yeah, the book is broken up into kind of different sections that cover this. And throughout it, there's actually a story of an SRE named Wiley and kind of her experiences of trying to get this to work within her company. So there's actually a story within the book. It's kind of cool. So something worth checking out.
So that's interesting. It's an interesting name. Is that based on a real person? Or I'm thinking back to the old days of APM, application performance monitoring, and one of the granddaddy products called CA Wiley.
Yeah. So Wiley, the product is talked about. I think I said it wrong. It's Riley is her name.
Oh,
sorry.
Riley. Okay.
I think I might have said Wiley. That was my bad. But Wiley, the company, is talked about in the beginning because I talk about the entire history of what the observability space or monitoring space has evolved into the observability space.
Okay, cool. And people can pick that up wherever their favorite IT books are available?
That's right. Yeah. Amazon, Barnes & Nobles, you name it. It's available online. You can get digital versions, physical versions. It should be available anywhere.
Okay, great. Yeah, what an amazing resource to have. Well, let's transition a little bit. You sound like you're a very busy human being. And on the show, we really like to talk about the human side of IT. And we know that burnout is a real issue in the IT world. And so I always like to get the perspective of everyone that I have on the show of how do they de-stress? What do they do in their life that takes them away from work and is just the thing that helps prevent burnout in their life? What do you do?
Yeah. So, I mean, family is very important to me. Anytime I can spend with a family, I think is great. And I think my biggest kind of hobby at the moment is exploring more of the world. So I'm very interested in different cultures, different foods, different languages. I kind of realized, especially as I got into college, that the world is a big place and a very diverse place. And so the more of it I can kind of see and experience, especially with others, especially with my family, I think is great generally. So I travel quite a bit. Sometimes it's for work, right? But also personally, whenever I get the opportunity to kind of visit a new place, I try to prioritize that.
Okay. I love traveling as well. So this is a great topic for us to quickly talk about. What are your favorite places you've been to so far?
Oh, so this is a hard question for me when everyone asks because I can't name like my top place. I can give you like a top 3 or 4, right? But they're all very different, which is why they're all kind of my favorites. So for example, I've been to Italy and I love like the Italian food. I love like the culture and history. The language is also very unique and interesting. And depending on where you go in Italy, it's also quite different. The cities themselves are not even the same. On the flip side, I really like Japan. And Japan, again, has a great food scene, but it's very different from Italian food. And culturally, it's also very different, right? There's a lot more structure there. Like trains are always on time. Like there's kind of this reliability aspect. There's a very clean city. There's no trash anywhere, right? Like they're just so different from one another. Or Iceland, like beautiful landscapes. Like in the same day, you can be like at a black sand beach, you can be on a glacier, you can be within a volcano, you can go see a waterfall. All very unique experiences in kind of one country. Or finally, maybe Sri Lanka. So I went with someone that is from Sri Lanka and got to kind of experience the actual culture and food that I otherwise would have kind of missed being a tourist. And so I got to see a side of the country that I wouldn't have otherwise experienced. They're all unique kind of places, right? And I don't know, the world is a fascinating place. And the more I get to see it, I think the better.
Well, you make it sound amazing. I've been to a couple of those places. A couple of them I haven't yet, and now I really want to go to those places. How many countries have you visited?
80, around 80 so far, and there's
80.
Around 200. So yes, depending on how you count them.
That's a huge number, by the way. Just having already visited 80, that's amazing. All right, I know where to go for my travel guidance now. If I ever travel somewhere, I think I'm going to hit you up on LinkedIn and ask you for some recommendations, probably.
What some people have joked about is my next book should be about travel.
Yeah, they're probably not joking at this point. We've had so many experiences. I would definitely read it. Maybe start a blog site, a travel blog. Have you ever considered?
Yeah, that's a good idea. I'll have to give that some thought for sure. Yes.
Yeah. Awesome. Okay. Well, listen, Steve, thank you so much for joining me today. That's going to be a wrap on this episode of Incidentally Reliable. For those listening, if you enjoyed today's conversation, we'd love for you to subscribe and to leave us a review. It really helps other people who are interested in reliability to find the show. So until next time, take care, and may all your on-call be incident-free. Thanks, Steve.
Thank you so much.